Hello everyone. In this video, I will be talking about population inversion, which is an important condition in order to understand the laser action. These are the contents of this presentation. So we are all familiar with the word laser, which stands for light amplification by stimulated emission of radiation. The word laser itself tells us that stimulated emission of radiation is required for light amplification. So what is laser? Lasers are the devices that produce intense coherent beam of light by amplifying light through stimulated emission. The key characteristics of laser are coherence, monochromicity, directionality, and high intensity. So population inversion is one such criteria or requirement which is necessary for the laser to work. Albert Einstein introduced the concept of stimulated emission. This idea of stimulated emission led to the invention of laser. Now let us understand what is population inversion. Population inversion is a condition in which more atoms are in higher energy state than in a lower energy state. When we talk about normal conditions, that is thermal equilibrium, most atoms are in ground state. Only few atoms are present in excited state. So stimulated emission is rare compared to absorption. According to Boltzmann distribution, N2 by N1 equals e to the power minus E2 minus E1 divided by KT. So in order to make the higher energy state consist of more atoms, population inversion is required. Without it, we cannot get proper amplification of light. Normal population versus population inversion. So let us understand what is the difference between normal population and population inversion. Here in both cases, N1 represents number of atoms present in ground state, N2 represents number of atoms present in excited state, E1 represents energy in ground state, and E2 represents energy in excited state. So first, let us see the left hand side, which is depicting about normal population. So here in this case, N1 is greater than N2, that is, more number of atoms are present in the lower state than in the higher state. So this is a stable condition. And this state is known as normal population, where the number of atoms present in the ground state is always greater than the number of atoms present in the excited state. So now let us see on the right hand side which shows about population inversion. In this state, N2 is greater than N1. That means more number of atoms are present in the higher excited state than in the ground state. In this state, the number of atoms present in the excited state is getting increased as compared to the number of atoms present in the ground state. But this is not a stable condition. To maintain this condition, we need energy, and the energy we are using is in terms of pumping. So population inversion is the precondition for the light amplification occurring in laser. This condition is neither a stable condition nor a natural condition. So the energy which is required is known as pumping, and the process in which the more number of atoms are present in the higher state than in the lower state is known as population inversion. And to achieve population inversion, pumping is required. What are the conditions to achieve population inversion? The conditions given here are external energy source, which is in the form of pumping, metastable state presence, and non-thermal equilibrium. External energy source or pumping. To achieve population inversion, source of energy is required to populate a specified energy level. This energy is called as pump energy. The process of supplying pump energy is known as pumping process. Metastable state presence. So what is metastable state? Metastable state is a state where lifetime of the particle is more in the excited state. So in order to achieve population inversion, metastable state is a necessary requirement because it will enable the atoms to stay for a longer duration of time. If there is no metastable state, there will be no population inversion, and if there is no population inversion, that means there will be no laser action. The next condition is non-thermal equilibrium. In order for the population inversion to occur, the system must be driven out of thermal equilibrium because under normal conditions, population inversion cannot occur. Now let's have a look on pumping mechanism. Pumping mechanism is a technique used to supply energy to a system. So the mechanism of obtaining population inversion in a system is known as pumping. It is the process by which atoms are raised from a lower to higher energy states. So there are different types of pumping methods such as optical pumping, electrical pumping, chemical pumping, gas dynamic pumping. In optical pumping, it uses light, usually flash lamp or another laser, to excite the atom. For example, a flash lamp excites electrons in the medium to higher energy states. For example, ruby laser. In electrical pumping, it uses electric current or discharge to excite atoms. For example, in helium neon laser, a high voltage excites helium atom, which then transfer energy to neon atom. So, helium neon laser is an example of electrical pumping. The next is chemical pumping. In chemical pumping, chemical reaction takes place. It is used in chemical lasers, etc. It can produce high power. The next one is gas dynamic pumping. It is achieved by expanding hot gases rapidly to cool them down and trap atoms in excited states. It is used in dynamic lasers. So let us understand about 3-level system and 4-level system. First, let us see about the 3-level system. Here we have three levels, E1, E2 and E3. E1 is the ground level, E3 is the excited level, and E2 is the metastable state. So, by pumping mechanism, we can raise the atoms from lower energy level to excited level. When the atoms are raised to E3, the lifetime of the excited state is very short, of the order of 10 to the power minus 8 seconds. So, these atoms in E3 will make fast transition to E2, which is metastable state. So metastable state is having a long lifetime. That means the atoms can retain for about 10 to the power minus 3 to 10 to the power minus 6 seconds. So population inversion is achieved between E2 and E1, and so the laser action takes place. Now here in the right hand side we have 4-level system. So in this case, the atoms are raised from E1 to E4. Now atoms will make fast transition to E3. That is the metastable state. E3 is a metastable state. Now the atoms will retain there for long time. So population inversion is achieved between E3 and E2. And so the laser action takes place. So what is the importance of population inversion in laser action? Population inversion is essential for laser action because it creates the necessary condition for stimulated emission. It enables stimulated emission, that is, more atoms in excited state allows photons to trigger more emission. It is essential for light amplification, that is, it amplifies the light through repeated stimulated emission. It produces coherent light, that is, it leads to the laser's characteristic property. It provides optical gain, that means it amplifies light effectively, which is the core of laser operation. It overcomes natural emission tendency, that is, in normal conditions, atoms spontaneously return to lower energy state, but population inversion reverses this condition, favoring stimulated emission, which helps in laser action. There are also certain challenges in population inversion, such as energy input requirements, spontaneous emission, thermal management, short lifetime of excited states, and multi-level system complexity. So these are the applications of population inversion. Actually, these are the applications of laser, we can say, but population inversion is a necessary condition without which laser action cannot take place. Without which laser action cannot take place. So here I have outlined about the applications of population inversion. They are used in laser technology, optical communication, holography, medical applications, industrial processing, scientific research, military and defense. So we can conclude by saying that population inversion is a very necessary requisite for the laser action to take place, without which the laser action will not be able to occur. So it serves as the foundational principle behind the functioning of lasers. Achieving this condition is both scientifically and technically challenging. Despite the difficulties, the ability to create and control population inversion has led to groundbreaking innovations in various domains. So thank you for watching this video.